I have shared my screen. Can anyone tell me if the screen is visible or not?
Yes,
Yes, ma'am.
ma'am. It is visible.
Yeah, thank you so much. So, a very good evening to one and all present over here. Today, we are resuming, and today is the day 4. I am going to discuss one sample t-test using SPSS today. So, in the previous 3 days, we have seen the basics of SPSS, that how to create variable, how to do data entry, or how to import data in SPSS. Then we have also tried to understood that how to recode the data, how to do the transformation. And then next day, I tried to explain you the reliability of the scale and the normality of the data. And then yesterday, we have seen non-parametric test, that is chi-square test, and we have seen goodness of it. And after that, I explained independence of attributes. Today is a day 4, and I'm going to discuss one sample t-test, right? So, yeah. Starting with the one sample t-test, firstly, we will understand its conceptual aspect, and then we will proceed with the applying of one sample t-test using SPSS. So, a one sample t-test is again a parametric test, means yesterday we have seen a non-parametric test. I tried to explain you the difference in the parametric and non-parametric test, where I told you parametric tests are generally bothering about the normal distribution of the data. They are considering the normal distribution of the data. And whereas when I talk about non-parametric tests, they are not at all concerning about the normal distribution of the data. Non-parametric tests generally deal with the categorical data, right? But whereas when we talk about parametric tests, in parametric tests, there would be the combination of categorical and the numeric variable. So when I talk about one sample t-test, one sample t-test is generally used to find whether the difference in the hypothesized mean and in the sample mean is similar or not, whether there is a significant difference existing between the population mean and sample mean. This is what we are going to check using the t-test. So we need to know, I don't know how many of you are knowing the formula of t-test manually. When we talk about formula of t-test manually, it is x bar minus mu divided by standard deviation divided by root n. So the numerator of the formula says x bar minus mu. X bar stands for the sample mean, mu stands for the population mean. So that means we are trying to find the difference in the means of population and in the sample, right? So this is what we are doing in the one sample t-test. Here in we will having the test value. The test value will be your value of the variable which you will be having. Now you need to compare your test value variable value with the test value, right? So two things are there: test variable. Test variable means the variable which you are having, and test value is what it would be the hypothesized value or it is the known value. This value would be the population mean value. So from the test variable, that is the sample mean, we are comparing the population mean. So once we will go in a species, we will find these fields there in the dialog box, and then again I'll explain you that how and what we need to transfer there, right? So now next is it is used when the population standard deviation is unknown. So it is very important to understand that when to use one sample t-test or a t-test. Whenever we are talking about the t-test is generally used when the population standard deviation is unknown, right? That means when we are not knowing what is the standard deviation of population, in that case, the suggestive tool is the t-test. And I think many a times we know in the researches we are dealing with the populations which are totally unknown for us. Means we cannot understand what is the total population, or we are not understanding or maybe able to collect the complete data of the population. In such cases, the suggestive tool is the t-test in comparison to the z-test, because z-test is used when the standard deviation of population is known to us. I hope the slide number 1 is clear. uh, I hope,
Yes, ma'am.
yeah.
Yes, ma'am.
Thank you. Moving ahead, talking about one sample t-test. This is the manual procedure which I am discussing. Usually, this manual procedure means whenever you are testing or applying the one sample t-test manually, we need to generally follow these particular things. But it is not like it is for the manual procedure. Even for the procedure which we are adopting through the softwares, in that also we need to define the null and the alternative hypothesis firstly. We need to have clearly defined null hypothesis and alternative hypothesis, right? After that, we need to decide upon what would be the alpha value. Alpha is the level of significance value. So this is what we need to maybe assume by our own selves, or if we are dealing with the class type, means numerical, which we are teaching to our students in the class. So in that case, in such questions, the alpha values are generally mentioned. But if we are talking about the research, in that case, being a researcher, we need to decide upon what would be the level of significance for us, means what would be the limit, or what would be the capacity of ours of committing the type 1 error, right? Then talking about the calculate degrees of freedom. After that, manually we need to calculate the degrees of freedom, but using software we do not need to bother about this. Software will give you or give us the values of value of degrees of freedom. Then we need to state the decision rule. This is the imperative part here. Means when we're talking about the decision rules, this should be beforehand known to us, that what would be the rule which we are applying on the output, right? So for example, we all know, uh, need to check, yeah, it is not there. So decision rule, I think we all know, there are decision rule based on the p value. P value means the probability value, right? So the decision rule or thumb rule says that when the p value is less than level of significance, we are rejecting the null hypothesis, right? But when the p value is greater than level of significance, in that case we are accepting the null hypothesis. So I think this would be the rule throughout the remaining days also we will follow. I hope the rule is clear and you people are knowing this, right?
Yes, ma'am.
Yeah, thank you. Talking about, then we need to decide upon which test we are going to opt here. So if, as here I'm talking about the one sample t test. So for one sample t test, we will having a single variable available with us, and that variable would be the numeric variable. And when we are comparing the numeric variable mean, oh sorry, numeric variable mean with the population mean. So in that case, we are interested to find the significance difference, right? So we will apply the one sample t test, and the formula for one sample t-test is t equals x bar minus mu divided by s divided by root n. And then after that, we are going to state our results, and we are concluding, we are giving the concluding remark, right? So that way, we can say this is the manual procedure, and somewhat this is the procedure we are also following using the softwares. I hope procedure is clear. Any doubt?
No, ma'am. No, ma'am. Please continue.
Thank you. Moving ahead, I need to show you the table of the one sample t-test. Although when we are talking about t-test using SPSS or Excel, we do not need to bother about the tables, right? But still, we can understand that when we talk about the manual procedures, we need to follow, or we need to have the value of table also. And using the table value, we can compare our calculator value to make a decision. So let me clear here one thing, that whenever we are talking about the decision rule, decision rules are based on the two things. One rule is based on the p value, and second rule is based on the critical value of the test, right? So for example, if I'm talking about p, so the critical value of t. Okay, so one thumb rule I have already explained you, that is the p value thumb rule, which says that when the p value is less than your level of significance, you are going to reject the null hypothesis, and vice versa, you will accept your null hypothesis. Using the critical value, if I say, so we are comparing the calculated value of the test with the critical value of the test, and then if calculated value is less than your critical value, you are going to accept your null hypothesis, and when your calculated value is greater than your critical value, you are going to reject your null hypothesis, right? So that critical value we can find using this particular table. For that, you need to have two things. One is your level of significance, that you can see in the very first row where I'm rotating my mouse, I'm hovering my mouse. And second one is the degrees of freedom. So for the one sample t-test, the formula of degrees of freedom is n minus 1, right? So that way, using these two parameters, using these two bases, we can find the t table value, right? Is it clear to all?
Yes, sir.
Further, talking about the hypothesis, right? So it is very important to understand. There are usually people get confused because in my class, students are getting confused because probably they are students. That is why they are asking such kind of questions. Maybe as I said, as I say that there is a one thing. There is a hypothesis. Hypothesis can be for the one-tail test or it will be for the two-tail test, right? So for one sample t-test, again the hypothesis can be of one tail or two tail. It is depending upon ourselves which type of hypothesis we want to create, right? In research papers. So here you can see the very first row is stating you that mu is equals to x bar, means population mean is equals to sample mean. And alternatively, I'm saying population mean is not equals to sample mean. That means here I can say this is a kind of two-tailed test hypothesis, right? Means the alternative hypothesis is saying that mu is not equals to x bar. That means it can be either greater than or it can be either less than, but I'm not clearly defining that. So that's why both the tails can be involved here. So we are saying this is a two-tailed test, right? But when we are clearly saying that mu is greater than or equals to x bar, or I'm saying mu is less than x bar, in such case, this is a one-tailed test, right? Then again, third condition can be mu less than equals to x bar and mu is greater than x bar. In such case also you can see we are clearly saying whether the mu is less than or greater than. In that case it is a one-tailed test hypothesis, right? Looking at the graphs, let me shift it here. Yeah, looking at a graph you can say, if I'm saying this is the bell-shaped curve, the normal distribution curve, so the rejection region in the normal distribution curve for the this particular two-tailed test will fall on both the tails, right? And this would be your acceptance reason of your null hypothesis. So this is the case of two-tailed test. But when you are clearly saying one-tailed test, in that case, your hypothesis, sorry, your rejection reason will fall at either of the tail. If you are saying this is your left tail test, so the rejection reason will fall at the left hand side. If you are saying it is a right tail test, so the rejection reason will fall at the right hand side of the tail. Okay, I hope this slide is clear. May I proceed? Hello.
Yes, ma'am.
Yeah, thank you. Now, the same thing which I have shown you in the previous slide. If suppose I want to write, in the previous slide we have seen the hypothesis in the form of symbols. But if I want to write my hypothesis in the form of words, in that case, I can say for the two-tailed test, I can say there is no significant difference in the sample mean and in the population mean. Alternatively, I can say there is a significant difference, right? So I'm mentioning there is a significant difference. Whether the difference is greater than or less than, that I'm not mentioning here. So that way, this is a kind of two-tailed hypothesis for one sample t-test. Now, talking about the one-tailed test, here I'm saying sample mean is significantly less than to the population mean, and I'm saying sample mean is significantly more than to the population mean. So that way, this is clearly I'm mentioning less than and greater than. So this is a case of one-tailed test for one sample t-test. Is it clear? May I proceed?
Yes, ma'am.
Yeah. Now talking about the important part of the t-test, that is the assumptions, right? So, just a minute. So there are total 4 assumptions. Yes, there are total 4 assumptions for the one sample t-test. The very first one is the dependent variable must be continuous. That is, it should be numeric variable, or I can say it should be a variable which should be measured on interval or ratio scale, right? So dependent variable means we will having only single variable. Firstly, you need to understand this thing. For the one sample t-test, we will having a single variable available with us, right? And that variable, we can say it is a kind of dependent variable, and the nature of that variable should be continuous, or you can say it should be a numeric variable, or a variable should be measured on interval or on ratio scale. This would be your first assumption, right? Second assumption is the observations are independent of one another. So that means if we are collecting our data from one person only once, that way we are able to maintain this particular assumption. So looking at the first two assumptions of one sample t-test, we can understand this thing. Here we do not need to apply any kind of statistics, right? Only observing, only by paying attention on the data, we can understand these two things, whether the data is following these two things or not. And in case of second assumption, we can say here we have to be very cautious while collecting the data, that we should need to collect the data from the one person only once, right? So that way these two assumptions we can easily check from the data itself, right? I hope these two are clear. May I move ahead for the next?
Ma'am, independent variable should be like uh, two different city or two different classrooms or two different states
I
or
haven't mentioned independent variable anywhere, maybe here. I'm only saying a dependent variable will be only one, and we are treating that variable as a dependent variable. I said this
okay.
thing only. Here there is a no rule of independent variable, because we are talking about a one sample t-test, and in case of, as the name itself is saying, one sample, we will having a single variable available with us. Say for example, weight of the students, or the scores of the students, or maybe the GDP of a country, right? So
Okay,
that way we will be having a single variable with us.
okay, okay, ma'am.
Yeah. So first two assumptions are clear. May I move ahead?
Yes, ma'am.
Okay, fine. Thank you. Moving ahead, talking about the next assumptions. The third assumption is saying the dependent variable should be approximately normally distributed. Means whatever is your numeric variable, you need to check the normality of that variable. And as I said previously, I think during when I was discussing the descriptive statistics, I said this thing. Usually in the real world, it is very hard to get a data which is exactly normally distributed. So that is why I have mentioned this term here, that is approximately normally distributed. That means your data cannot follow exactly all the characteristics of the normal distribution, but some way it is meeting them, or it is very close to those figures, right? So that way we can conclude that the dependent variable is approximately normally distributed. Usually to check the normality, I think I discussed previously, we can use the graphical methods and we can use the numerical methods. So in the graphical, you can use histogram, you can use scatter plot or QQ plot. And in the numeric methods, you can use the mean, median, mode, standard deviation, sorry, mean, median, mode, skewness and kurtosis. And also you can use the Shapiro-Wilks test or the Kolmogorov Spin-Now test. So this way you can check the normality of your data. The next assumption says the dependent variable, that is the numeric variable, should not contain any outliers, right? So whatever is your dependent variable, whatever is your numeric variable, you need to check whether there is any significant outlier available in that or not. So that way, these are the four assumptions you need to check for your data before applying the one sample t-test on that. Is it clear? Sorry. Sorry. Is it clear? May I move ahead?
Yes, ma'am.
Yeah. Thank you. Now, talking about the normality of the data, as I said, using the histogram also, we can check the normal distribution of the data. So say, for example, here you can see we are having a graph. In this graph, you can see the graph is not equally distributed. Bars are not equally same at both the sides. Of the higher bar, both the sides, you can see the bars are not equally distributed, or the bar length is not same, right? So that way we can see it is not exactly normally distributed, but somewhere I can say that this particular graph is saying that the variable is approximately normally distributed. So means purpose of this particular graph showing here is that, means if you are getting such kind of graphs, So somewhere you can conclude that your data is approximately normally distributed. Further, talking about the outliers, so the box plot we are using generally to find or detect the outliers in the data, right? So that way you can see these, I think previously also we have seen the box plots, right? So here, depending upon what is the size of your data, what is the maximum and minimum value you are having, according to that, this size you can see of the box plots. And you can see these circles, I told you previously also, these circles are known as generally the outliers, right? And for the significant outliers, we are getting the asterisk sign in SPSS. So looking at the data, we can check this thing, right? That whether the data is having any outlier or not. So this way, we can check the assumption of the what I can say, one sample t-test. Further, you can see some more graphs I have taken here to show you these are the histograms and the QQ plots. So looking at the histogram, I think now you got a little understanding. I think from histogram we can somewhere conclude about the normality. QQ plot is also helping you to comment on the normality of the data. So if whatever is your fitted line, whatever is your trend line, if your data is exactly following that line, you can say your data is normal. But if it is showing some curvy type of distribution like this, so that way you can conclude that your data is not exactly normally distributed, right? Is it clear? Here you can see this is your positively skewed QQ plot, this is your negatively skewed QQ plot. Is it fine? May I proceed?
Yes, ma'am.
Yeah. Now, how you can apply one sample t-test in SPSS. So I think rather than reading, we will go and we will check there that how we can apply one sample t-test using the SPSS. For that, I think I have shared a sheet with all of you, and I'm expecting you all will be having the sheet, right? You are having?
Yes, ma'am.
Yeah. So I think you can see, I hope you all have opened the sheet. If you are performing along with me, I have given you the species file, .sav file, I think I have shared with all of you. So you can see in this particular, uh, what I can say, sheet, we are having the two variables available, score and the IQ score, right? Score means marks of the students, and this is the IQ score of the students. Let me open one file. Give me a second. I'm putting it in a chat for you. You people can read from there. I am giving you a situation. I think I had typed the situation in the chat. I hope you all can see. Yeah, is it visible or not?
Yes, ma'am, visible.
Yeah, thank you so much, ma'am. I'm expecting everyone to please read the situation which I have given you in a chat box. Visible to everyone? Have everyone has read the question?
Yes, ma'am. Yes, ma'am.
Yeah, thank you, Amit sir. So you can see this particular question is saying we are having a 40 students data, and from past 30 years, on the basis of the experience of past 30 years, we can say the average score is approximate 78. Reading score is approximate 78. Now we need to check whether whatever sample we have taken, that particular sample is also having the same thing or not, right? That we need to check. Give me a second. Yeah. So now, suppose I'm talking about the score variable, as I again repeat the same thing as we are talking about the one sample t-test. So for one sample t-test, we are considering only one variable. Although I have given you two variables, so the purpose of here of giving the two variables is that for score I will check the one sample t-test for you, and for IQ you need to check the one sample t-test, right? You need to apply the one sample t-test on IQ, right? So here you can see we are having a score variable available with us. So firstly, we need to check the first two assumptions, right? So the first assumption says is your variable is so the first variable says that it is a score, it is a kind of numeric variable. Can I say this is a numeric variable because these are the scores? Can I say?
Yeah, yes.
Yes. So this is the first assumption. We have checked that the variable should be numeric. We can treat this variable as a dependent variable. Second assumption says that there should be the independency in the observations. The observations should be independent of each other. So here we can assume that we have collected the data because this is the data which I have given to you. Once you will collect the data by your own, you need to be very precautious that from the one person you need to collect the data only once, right? So we can assume that from one student we have collected the score of one student only once, right? So this way first two assumptions we have checked here. Talking about the next, we need to check the normality of the data, and then we need to check the outliers in the data. That is, in the score we need to check whether the scores are normally distributed or not, or whether these scores have any outliers available or not. So can anyone tell me how we can check that? Because I think I explained this thing. Can anyone tell me what I need to do here?
I think we have to go to analyze, then descriptive statistics, then explore.
Okay, who is speaking?
Uh, I'm Prerna, ma'am.
Yeah, very correct. Very correct. We will go to the analyze, we will go to the descriptive statistics, and then we will go to the explore. Very good, Prerna ma'am. Impressive. In our first interaction, you have understood how to do that. Very good. So we are going to the analyze menu. We are selecting descriptive statistics, and we are selecting explore. So is it fine? May I press or may I select this explore here?
Yes, ma'am.
Yeah. So we are opening the explore. Here you can see score is listed at the left hand side. You need to select it and transfer it to the dependent list box like this. I hope you people have performed it.
Yes, ma'am.
Yeah. After that, you need to go to the statistics. As I said previously, under this explore statistics, we do not need to do anything. Whatever is the by default option, that option is sufficient for us to get the results, right? So you can press continue here. Go to the
Ma'am, we can also take on outliers also here.
if you want, you can take them. Otherwise, you can click on the plots because under the plots already this box plot is coming,
Okay, okay.
right? So next you need to click on the plots only. You need to click on the plots button, right? Here,
Okay,
at the
okay,
left
ma'am.
hand side, under the box plot, you can see the by default option is factor labels together. I think previously I said factor label come. This particular thing is what factor is known as the independent variable. Here we are not passing anything under the factor list, right? So that means there is no meaning of these things. Whatever is the by default option, we will go with that only, right?
Okay,
Under the
ma'am.
descriptive, yeah, thank you, ma'am. Under the descriptive, we will not go with the stem and leaf. This is a very older process to understand. We will go with the histogram. Along with that, we need to check this normality plots with tests. These things we need to do here to get the output. And then we can click on the continue button. So may I click on the continue button?
Yes, ma'am.
Yeah. Now we need to click on the just OK button to generate the outputs. So within few seconds, your output will be generated in the output viewer. So today, how many of you are performing along with me?
Doing, ma'am.
Yeah, Nitya ma'am, thank you. What about the remaining? Okay, Veera sir is saying okay.
Yes, ma'am. We're doing.
Manu sir, Madhvi ma'am, very good. Thank you. So I think I need to check my output is generated or not. Yeah, it is generated for me. I think yours, you are also getting the same outputs what I am getting here, right? So may I start explaining?
Yes, ma'am.
Yes, ma'am.
Yeah. So the first option or the first table is the case processing summary. Here you can see we are having total 40 observations for the score. There is no missing value available. So that is why the total is same as 40. Coming to the descriptive statistics, you can see score mean is 68.53. 95% confidence interval for mean is 63.23 and 73.82. This is a range, right, of the 95% confidence interval for mean. 5% trimmed mean, meaning is if we are removing the outliers from 5% outliers from both the sides, so this would be your mean value. Median is 68. Variance is 273.846. Standard deviation is 16.548. Minimum of the score is 35. Maximum is the 100. Range is the 65. Interquartile range is 65. And the skewness and kurtosis figures are minus 0.112 and minus 0.785. Right? Now coming to the next, that is the test of normality. I think before talking to this, looking at the mean and median figure, we can say these two figures are very close to each other, right? 68.53 and 60. Can I say these are close? Yes.
Yes, ma'am.
Yeah. So that means here I can, looking at these two figures, I can somewhere say that might be possible the data is approximately normally distributed. Second thing is you need to check the skewness and the kurtosis figure. Here kurtosis and skewness are in the threshold range. I think the ranges I have already explained you. For skewness, we can take it as a plus minus 2, and for kurtosis we can take it as a plus minus 3. So both the figures are coming in the range, right? So that way we can say, looking at these characteristics, somewhere we can say that the score variable is the approximately normally distributed. Now to ascertain this thing, we are talking about the test of normality. So the test of normality table shows us the Kolmogorov-Smirnov test results and the Shapiro-Wilks test results. So here we can say here we need to report the Shapiro-Wilks test. So we can say here that the Shapiro-Wilks test significance value is 0.696. So I think you can recall I have told you the hypothesis also for this. Can anyone tell me what was the hypothesis? Yes. What was the hypothesis?
No significant difference in sample mean and population mean.
Ma'am, that was for the t-test. For the Shapiro-Wilks test, what was the hypothesis? Anyone?
Tentative guess.
Yeah, definitely. So these are not the like classes like where I'm going to give you a punishment or something like that. Yes, please.
मैम ये बोला टेंटेटिव गैस है ना, मतलब एक तरह का हाइपोथेसिस में ये है कि मतलब हमने हाइपोथेसिस जो गेन किया है ना मैम, मतलब हमने जो लगाना है ना,
जी
जो भी हाइपोथेसिस हम कर रहे हैं मैम,
जी
वो चाहे अल्टरनेटिव है चाहे नल हाइपोथेसिस, जो भी हम कर रहे हैं अकॉर्डिंग टू हमें अभी कोई भी पता नहीं है, वो एक तरह का टेंटेटिव गैस ही है। मतलब कि हमने जिस तरह के अजम्पशन को फुलफिल कर, जैसे आपने अभी बताया था ना मैम कि जो अजम्पशन हम कर रहे हैं,
हम्म
जो अजम्पशन हमने लगाई टेस्ट के लिए, जो
हम्म
भी हम देखना चाह रहे हैं उसके लिए,
हम्म
वो जो हाइपोथेसिस हमने गेन किया उसको चाहे रिजल्ट्स के बाद वो सिग्निफिकेंट आ रहा है चाहे नॉन सिग्निफिकेंट है, फिर वो वहां पे जाके एक्सेप्ट या रिजेक्ट हो सकता है।
Okay. Probably, I think, sir, you have not got what I am asking. I was saying this. I think I need to speak in English only, right? You
Yes,
people are
yes, ma'am,
comfortable in
please.
English, no? Yeah.
Yes, yes.
Yes. So I was saying this thing that what is the hypothesis for Shapiro-Wilks test? I'm not asking you what is the hypothesis or meaning of hypothesis. I'm only saying what can be the hypothesis for Shapiro-Wilks test. I think you people are not able to recall. I have told you this. If not, you can write down this hypothesis. So the hypothesis for Shapiro-Wilks test will be the variable is normally distributed, right? This would be your null hypothesis. I think I told you this thing. I don't remember, but here I'm writing that for Shapiro's Wilks test. Hypothesis that is H naught will be variable is normally distributed. This would be the hypothesis, right?
Okay, ma'am.
Yeah. So now looking at the hypothesis and now coming to the results. So now looking at the results, that is the significant value is what? It is 6.696. So what I can say, our p value is equals to 0.696, which is, I think, quite clear. It is greater than 0.05, right?
Yes, ma'am.
So if this is what we will do, we are going to accept the H0 or we are not going to reject the H0, right?
Yes, ma'am.
Yes. So if we are not rejecting this null hypothesis, that means we are concluding that the variable is normally distributed, right?
Yes.
Yes, ma'am.
Right. So that way, this is the normality uncertainty of the using the Shapiro-Wilks test. Coming to the next, talking about the histogram. Although histogram is not clearly stating something here, but still, if you want to put a curve, bell-shaped curve, you can double click on the area of your histogram. You can then come here and you can put a bell-shaped curve on this particular graph. You can close your chart editor and you will be able to see this is your bell-shaped curve on the histogram. So somewhere looking at the diagram, we can say somewhere looking at the diagram, we can say, or looking at the bell-shaped curve, we can say that yes, somewhere we can conclude on looking at the histogram also that the variable is approximately normally distributed, right? May I proceed? Yeah.
मैम कोल्मोगोरोव और शैपिरो-विल्क दोनों में से शैपिरो-विल्क टेस्ट को ही कंसिडर करेंगे?
Usually, I think previously during the normality and reliability session, I explained this thing. When the sample size is large, we will go for the Kolmogorov now. Sample size is smaller, we will go for the Shapiro-Wilks. Usually in the literature, what I studied, if the sample size is less than 1,000, so we will go for Shapiro. Or in the case of higher size of the sample, we will go for the Kolmogorov.
Okay, ma'am. Thank you.
Yeah. So may I proceed to the next?
Yes, ma'am.
Yeah. Looking at the QQ plot, quantile plot, again you can see this is your fitted line, this is your trend line, and your data points are almost following your trend line, right? So again we can say this thing that looking at the QQ plot, somewhere we can conclude that the variable is approximately normally distributed. Now the trended normal curve you do not need to include in your results. Coming to the box plot, looking at a box plot, you can see it is a very decent type of box plot. No outliers it's coming here, so we can say there is no outliers available in the data, right?
Yes, ma'am.
Right.
Yes,
All
ma'am.
assumptions we have checked. May I proceed now?
Yeah, yes.
Yes, ma'am.
Yeah. So now we will go to perform the, just a minute, one sample t-test, but here I'm writing the hypothesis. There is no significant difference in the mean sample score and mean population score, right? This would be your null hypothesis. Is it fine? I hope you have noted down.
Yes, I'm done.
Yes, ma'am.
Yeah. Moving ahead, talking about how to perform the one sample t-test, you need to go to the analyze menu. You can select compare means, and then here you can select one sample t-test. So this is the process of reaching to the one sample t-test test in the SPSS. I hope you have found it. You have found this?
Yes, ma'am. Yes, ma'am.
Yes. Now you can select this one sample t-test. You need to shift your score variable. As we are talking about the score variable, you need to shift this variable to the test variable. I think now you can connect with the things which I have shown you in these slides. I think there was a word written with that is test variable, right? So test variable means the variable which we want to test, which is a score, which we are shifting in the test variables box, right? Now coming to the test value. Test value is your hypothesized value, right? This will be the known value to you. Can anyone tell me what will be this value? Yes. Any guesses for this? Yes. Any guesses? Sorry?
78, ma'am.
Very good. Who said this?
Veera.
Very good, sir. It's 78. Correct. In the problem itself, it is mentioned that with the experience of school, they are saying usually the average score since last 30 years is 78, right? I hope you understood from where the sir has said this thing. This is what I want to explain you at that time of the slides, that whenever we are talking about the one sample t-test, we need to have an idea about the population mean, right? So that is the value which you need to fit here, which you need to put here under the test value. I hope it is clear to all.
Yes, ma'am.
After that, I think nothing we need to select here, but still if you want, you can go and check in the options. It is showing you the confidence interval percentages. It is 95%. But if you want to check your hypothesis for 99 or suppose 98 or whatever percent, 90%, whatever you want to check, that percent you can change here. It is totally up to you, right? But by default, most of the softwares are based on the 95% confidence level or 5% level of significance. So I think I am being a person from the social science, as I'm from management. So I usually check my hypothesis at 95%. Up to you if you want to make changes that you can do according to the sensitivity of the field. We need to select this percent, right? And then we can press on continue button. And I think may I press on OK? No, right?
Ma'am, what is the significance of bootstrap?
Bootstrap is generally we are doing when we are not knowing the things in a better way. So in that case we are doing, but once you will run this particular bootstrap, it takes so much time because it will create the samples of same size. Here we are having a very small size of the sample, that is 40 only, right? But what it does, The software will create so many samples of size 40, and that way it will give you the precise values, right? So that you can do, but I think here there is no need of that.
ओके,
Yeah.
तो मैम बेसिकली कब यूज़ करते हैं उसको?
Up
जब
to us, ma'am, if you want to run through that you can do. But usually for the research point of view, means the research paper writing point of view, options is fine for us. Although in each and every software, this bootstrapping, each and every statistical test in SPSS, bootstrapping is given to us.
ओके,
Yeah. So may I go ahead?
यस मैम।
Yeah. I'm pressing on OK to generate the output. I think in a second, in few nanoseconds, we have got the results also. I hope you have also generated the results.
Yes, ma'am.
Yeah. Now, you can see the first table is the one sample statistics table. So the one sample statistics table is showing you this is your variable, that is score. N is the sample size, which is 40. The mean of the score is 68.53 and the standard deviation of the score is 16.548. Standard error of mean is 2.617, right? Generally, for finding the robustness, ma'am, I think I don't know who was speaking previously for bootstrapping. As my slide, as my screen is something different. As I have shared my screen, I cannot see anyone at the back side. So bootstrapping generally we usually we do for the calculation of a standard error of mean also. Generally that is the purpose, because this standard error of mean plays some important role. As you know the formula, I need to check, show you once again, just a minute in the slides. I hope slides are visible. Visible, right?
यस मैम।
Yeah. Here you can see this term is known as the standard error of mean. S divided by root n or sigma divided by root n. This is known as the standard error of mean. So to get the precise value of this, generally we are performing, I can say bootstrapping, right?
ओके मैम।
Yeah. Now coming to the next table, that is the one sample t-test. Here you can see test value we have taken as 78, which is shown by us, which is shown to us by the SPSS. Now coming to the next score, and the t value of this, t is the calculated t value, which is minus 3.621. Degrees of freedom is 39, as we are having 40 observations. So in case of one sample t-test, I told you the degrees of freedom formula is n minus 1. So it is 40 minus 1, that is 39. Significance value for the two-tailed test is coming as 0.001. So this significant value, it is less. Significant value means the p value. This p value is less than 0.05, right? So coming here, not here, on word file, yeah. So coming here, we can say the p is less than 0.05. So what we will do here? Anyone? If p is less than 0.05, what we will?
Reject. Reject null hypothesis.
We will reject. Very correct. We will reject the null hypothesis. And if we are rejecting the null hypothesis, that means what we are concluding? We are concluding that there is a significant difference in the mean sample score and the population sample score, right? And we can come here and we can check the mean is 68.3 of these scores, right? Is it clear? And the difference means the difference is coming as minus 9.745, or I can say the difference is coming as 9.745. So that means population mean and the sample mean difference is this, or 78 minus 68.53 will give you this 9.745. So this difference is the significant difference, right? So we can say population mean and sample mean are not matching. They are different to each other. Is it clear to all? Any doubts so far? Okay, no voices are coming. Is it okay?
यस मैम, यस।
Yeah. So I think this is a one sample t-test from my side. Now I'm expecting you people to perform the one sample t-test on IQ score using the assumptions, means checking by checking the assumptions, and then you need to tell me the results on the chat box. So I'm waiting for your results. Or meanwhile, if you are having any queries, you can ask me. I hope you people are performing, right? No confirmation, I got it.
Yes, ma'am. Yes.
Thank you so much, ma'am.
Mean 109.64.
Okay. Have you checked all the assumptions, ma'am?
1 second, ma'am. And 1 second.
Yeah, yeah. Meanwhile, I'm
Ma'am?
also performing for, yes.
Ma'am, for doing that one sample test for IQ, again the test value.
Test value will be different, sir. Although in question in the problem which I have shown you, it is not mentioned, but usually from the experiences, we know for a normal person, the average IQ value is 100. If
Okay.
I am a normal person, means I do not have any mental problem, that means my IQ should be at least 100.
Okay, ma'am.
So we can say the average IQ value will be 100.
Hello, ma'am. Here also, should we start with normality and then move into t-test?
Yes, yes. We need to always check, ma'am. Usually, many times people are doing such kind of things. They are not checking assumptions, but might be possible in some cases. Maybe the journals can raise questions and they can ask you. So, if you are checking, you can strongly write this thing that the variable was normally distributed or approximately normally distributed.
Will you please repeat it, ma'am?
From where, sir?
T-test, ma'am. Yeah.
How to perform?
Yes, ma'am.
Okay. You need to go to the analyze. You need to go to the compare means and you need to select one sample t-test. Fine.
Yes, ma'am. Yes,
Then
ma'am.
you need to shift your test
Three.
variable. Sorry. You need to shift your test variable from left box to the right box using this arrow. I did. I have. Okay, just a minute. I think I forgot to share my screen. Sorry. My mistake. Yeah. Yeah. Just a minute. Again, I'm repeating. Analyze. Compare means
No,
one sample t-test. Here you need to shift your test variable from left
Not
box to
visible.
the right box using the arrow and you need to transfer or you need to type the test value here. That's all. This is all what you need to do here and you need to press on OK button to get the output. So is it fine, sir?
sorry, ma'am, but not visible. Ma'am.
Sorry?
Not visible, ma'am.
My screen is visible to anyone?
Done, ma'am.
Yes,
Done.
ma'am, it is visible.
Okay. Okay. So I hope, sir, you need to check. You need to pin my screen to see my screen.
Yes, ma'am. Done, ma'am. Done.
Yeah. You can press on OK to generate the output, and this is the output of the IQ. I hope you all have got the same, but firstly, you need to tell me whether the IQ is normally distributed or not.
Yes, ma'am. It's normally distributed.
Okay, great.
I have shared the answer in this chat box.
Just a minute, I'm checking. Yeah, very correct.
मैम टेस्ट वैल्यू में कितनी वैल्यू थी 100 थी मैम
100. 100 we need to keep,
जो
sir. Sorry? 100 we need to
जो
keep.
रिजल्ट आप
Sorry?
हमारा रिजल्ट नहीं जो रिजल्ट आपका है ना मैम वो नहीं आया मेरे पास
Okay, what results you are getting, sir?
मैम नंबर ऑफ 39 आ रहे इसमें मीन है 164
Madan sir, can you share your screen? Is it possible for you to share?
यस मैम
Okay. Yes, Manu sir, I have seen your results also. Madan sir, are you sharing? We are waiting.
यस मैम
Yeah. Madan sir, or do I need to share my screen? Hello, Madan sir, are you here?
मैम मेरा ना कैमरा प्रॉपर्ली नहीं
Sorry?
कैमरा वर्क नहीं कर रहा मैम प्रॉपर्ली
Okay, no issues. I'm sharing my screen. You please tell me what problem you are facing.
ओके
Okay, this is the results with what we are getting. I hope you are getting the same results. I don't know what you did, sir. I need to check. That is what I'm saying. If you can share your screen, I can see the things. But
No,
if
ma'am.
not,
I'm also getting number of observation as 39, ma'am.
Even I'm getting 39 now.
just a minute. But how it is possible? I think I have shared the same sheet which I'm using here. You can check in your data view, ma'am. Come to your
Ma'am,
data.
yes.
Ma'am,
there is some
ma'am, same I
observation
am
Ma'am, actually
same 39.
40 it is
blank,
it is
blank.
those IQ it is not showing, ma'am.
IQ it is not showing me. Data is not there.
Yeah,
Mhm.
yes, sir.
Can I share my screen?
Yeah. I do not have any problem. Anyone can share. Anyone can share.
मैम मैंने वो ग्रुप पे भेजा है मैम
Ma'am, this one.
Oh, shit. Is not visible. Just
It
a
is
minute.
fluctuating.
Yeah, please wait, but it is not visible to us. You need to show me your data file, ma'am, not this. Go and check your data view. Okay, I think.
Ma'am, in
Ma'am.
data, number 40, it is empty, ma'am. There is
That
no
is why.
values.
That is why you can fill that value. The value is in my sheet. The value is 118. You can fill that value, no problem. And then run it again. Fine. Is it fine, ma'am? Or else
Ma'am, I am not getting
what?
Yes, ma'am. Done, ma'am.
how 40 comes.
Oh, 40 comes. Priya, ma'am, what are you saying? I'm not getting your point.
मैम आपका 40 आ रहा था जब आपने स्क्रीन शेयर
I
की थी
think the
और
same
मेरे में
thing
नंबर ऑफ ऑब्जर्वेशन 39 है
Priya, ma'am, you need to be attentive during the online classes. Nitya ma'am is saying the same thing. Actually, I said you people need to check your data view. In data view, you are having 39 observations. That is why.
Now
Yes, ma'am.
it's correct, ma'am. 40
Yeah,
it is appearing.
yes. So you need to enter 118 because my 40th observation is 118. This is what I'm saying, Priya ma'am. Are you getting my point now?
या गॉट इट मैम
Yeah.
थैंक यू मैम
Most welcome, ma'am.
yes,
So any
40 वाली है
other?
ना मैम वो last
Sorry.
मैम
Yes, Madan sir.
मैम जो ये 40 वाला है ना IQ लेवल, वो लास्ट वाला खाली था मैम ना?
हाँ जी, हाँ जी, हाँ जी, वहां पे यू नीड टू राइट 118.
118?
हाँ जी, 118.
ओके मैम,
Yes.
ओके मैम।
Yeah. I hope you all have got the same outputs now. Results are similar. Variable is normally distributed and there is no outlier available. And according to your results, probably we are going to reject the null hypothesis. I need to check. Right? We are going to reject the null hypothesis and the significant value is coming as 0.000. Right?
Yes, ma'am.
Yeah. So I think this is the one sample t-test. We will discuss the independent samples t-test tomorrow. Although in this particular module, paired sample t-test is not mentioned. So what I'll do tomorrow, I'll discuss both independent samples t-test and paired samples t-test, right? So we will take both the tests tomorrow and that way we will proceed further. So I think this is all from my side for the day. Now I'm expecting your queries. If you are having any, you can please start asking. Platform is open. I am waiting for your questions. If you are having any questions, you can please ask me.
Ma'am, for IQ, this test value will be 100, no, ma'am?
Yeah, because ma'am, if suppose in my class I want to order, suppose I want to order the the cloth for making the blazer for my students, right? So in that case, I need to know the height and size of the students, right? So that's why I need to take a assumption. So maybe I need to understand what is the age group of the students, and accordingly, from the statistics or the statistical reports of government, we can check what should be the height of the students for that particular age group, and accordingly we can decide upon how much cloth is requiring for making one blazer for a student. Accordingly I can give an order. So that means such kind of things you need to have a idea about the population. So here I can say for IQ, generally for a normal person, IQ should be minimum 100. So that is why I said to you people that the average IQ value should be 100, right?
Oh, okay, ma'am. Right, fine. Thank you.
Yeah. Any other queries? No queries? So can we close for our day now? Can we call off a meeting?
Yes, sir.
Okay. Before calling off a meeting, can any one of you open your cameras to capture these pics? Okay. Great. Thank you. I have captured. Thank you. Sir, just a minute. Veera sir, I think I haven't captured you. Just a minute. Okay, so this is all from my side for the day. Take care, everyone. Good night. We will meet tomorrow and discussing the independent samples t-test and the paired sample t-test. Thank you, everyone.
Thank you, ma'am. Good night.
Thank you. Good night. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
ma'am.
Shatavam. Thank you, everyone.
Thank you,
Yograj
ma'am.
sir, are you here? Thank you, Shatavam. Yograj sir, are you here? Yograj sir? Yograj sir, are you here? Yeah. Sir, we are closing the meeting now as the content is discussed by me for the day. Thank you so much, sir.